Hello, everyone, and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our session today will cover securing the Oracle database, the solutions that are available, what's planned next, some advantages that customers have, and how easy it is to get started. I'd like to introduce Jean and Joseph as our main presenters. And now I'll hand it over to Joseph to begin today's session. Thank you.
Thank you, Brandon. Okay, so here's our agenda for the day. We'll be discussing securing the Oracle database with our maximum security architecture presentation, and then I'll be passing it on to my peer, John Sartor, to look at a customer case study. First, a little housekeeping, safe harbor statement. This just means that if we discuss any future technology, you want to just be cognizant that to make any purchasing decisions based on the existing technology. Okay, let's talk about the maximum security architecture. No single thing really makes a database secure or makes your data secure. If that were the case, we would just do it and we would all just move on and that'd be the end of it. But really keeping your data secure requires numerous different techniques, different capabilities all working together to close those gaps, the various vulnerabilities that an attacker could potentially try to leverage to slip through when stealing the data. So to begin, let's set a little context at the very beginning. What is a database, right? Seems pretty obvious, but sometimes not so much, right? The database, this is your sometimes valuable repository of sensitive information. Sometimes it's not as sensitive. Typically, it's a mix of the two. And a data thief is almost always going to target the database in an attempt to steal that data. And before we think about defending against this type of attack, let's set a little context and look at how these attacks might normally occur. The database persists data into storage medium on the database servers with your operating systems and your peripherals. And then we have all of our subprod copies. Typically, you've got copies for your dev, your QA, UAT, and so on. The database is accessed by users and applications. And then all these are managed by your administrators. If you're trying to break in and steal this data, you can try to attack any of these areas to gain access. But the administrator, this is an attacker's favorite point of attack. If they're able to compromise an administrator account, they're typically in with very elevated privileges. In many cases, almost no constraints on what the user can do. If an attacker is unable to compromise the kind of bigger target of an administrator account, they may often go after just any account. And the methods are pretty well known to most of us: phishing, malware, breaches on unrelated websites because of password reuse, unfortunately, brute force attacks, just trying over and over again to get into that account, unsecure use of public Wi-Fi. Or one of my favorites as a former DBA was simply users passing around, sharing passwords to, trying to get their jobs done and sort of just violating policies and sharing credentials. In all these cases, we have lower privileges, but we still have access to data. And this actually can be very advantageous, believe it or not. With this lower privilege user, the bad actor could attempt to use it as a stepping stone to get higher access through a method known as privilege escalation. Very simple idea. Get in however possible, and then find a vulnerability, or more typically a series of vulnerabilities. And then little by little, you want to try to get these users to a higher level of privilege. Applications, they also make a very attractive target. They're actually frequently more exposed than the database or the database server, often even available from outside of those corporate firewalls. And speaking of the firewalls, if an attacker has managed to penetrate your firewall to reach that internal network, they may simply choose to go after that data traveling over that network. In this type of attack, it's typically a lot more difficult to detect than attempts to actually access the database directly. Another popular attack used to be fairly uncommon is against the underlying data files, the database backups or the exports. If an attacker is successful in this case, they may be able to steal the whole entire database without ever trying to log into it. They could take it somewhere else and then try to access that data at their leisure. Ransomware is an example of a common database bypass attack, right? Used to be common, now ransomware is in the news very regularly. If none of these things work, then maybe the database hasn't been patched for a while. I see this all the time. Sometimes I see systems that are behind in patching, 1 or 2 patches, sometimes many, many patches, sometimes for years. Unfortunately, the contents of patches are known to everyone, so bad actors can leverage this information too. And if you hit Google and you dig down enough, sometimes you can even find automated or semi-automated attack toolkits that are actually designed to exploit these vulnerabilities in specific database versions. And then we can't forget these non-production copies of subprod databases. When I was a DBA, I would often see production be cloned, and then they'd say, okay, this is subprod, right? But it was just simply a straight clone of production, right? And then what I would see also is that the level of protection would often drop significantly. And so you've got basically all your production data in a less secure environment. So now that we have a little bit of context, let's talk a little further about what we call baseline security. There's some things that we always expect to be done, what we call the baseline security posture. And establishing this baseline security posture involves several different types of controls for preventing and assessing and detecting activity that's relevant to our security controls. So our first control is assessing the database configuration. We want to ensure that we haven't made configuration decisions in the past or have inherited possibly some decisions that have introduced or have left unnecessary risks in our environments. We'll also check to make sure that the database is it's current on security patches, for example. For this, we have 2 tools available to us. We have the Database Security Assessment Tool, we call it DBSAT for short. And we also have DataSafe. DBSAT is a free utility available for download via My Oracle support. And DBSAT can also be run from Enterprise Manager as well. DataSafe is a cloud service that's included at no cost with Oracle Cloud Database Services. DataSafe is also available for on-prem databases, but there's an additional cost for those. You see my little asterisk there in the corner. So users and applications, they're connecting to the database, and we want to ensure if we're using, or if our users are connecting with username and passwords, we're practicing this good password discipline, right? We also want to consider a more robust authentication. Your Oracle database supports Kerberos, PKI certificate. There's also Azure AD OAuth 2 tokens, Oracle Cloud IAM for passwords and tokens, and Radius. Also, multi-factor authentication can be achieved through most of these authentication methods. Then, depending on how many users connect to our database and how many databases we have, we may want to consider implementing some type of a centralized authentication. Your Oracle database supports 2 types of centralized user management. One feature, Enterprise User Security. This is available on all currently supported database versions. And this allows the Oracle database to consult an Oracle LDAP directory for users and role membership. The other feature, centrally managed users. This was new in 18C. And this allows the Oracle database to connect to a Microsoft Active Directory for user and role membership. We also want to make sure that those users really should be able to connect to the database. When I was in DBA, I got more and more into the security side of things. This is one of the first things I did, looking for dormant accounts, checking to be sure that we hadn't over-granted privileges that just maybe don't make sense in our environment. One example is I uncovered, we had a VP that had started off as a developer. Over many decades working with the organization, he had spent many, many, many years in the database. And as a result, he had astronomical privileges that just simply were not appropriate anymore. Here again, this is where DBSAT and DataSafe can help by pointing out things that don't make sense, things like inactive accounts or users with select any table privileges, or what I often see is excessive grants of the DBA role, for example. Right? So we want to bring these things to the forefront. We should also check that the database users actually have privileges that they're using. When I was a DBA, same time frame, I was learning to lock down my systems, and I uncovered what I thought was a trove of developers that had excessive privileges. I compiled my notes and went to the development manager and said, "Hey, look at these users have really elevated privileges," and I was told that they were needed and that they were being used, and I just needed to go away because they were busy. Right. What I wish I'd had was privilege analysis. This is a tool that you can turn on, leave on for a period of time, and it'll show you the privileges that users have that aren't being used. And then you can actually gather this data and make some good decisions that conform with your policies, um, which likely would be removing unnecessary privileges, right? So really the goal here is to reduce the attack surface presented by privileges that aren't being used. So privilege analysis will go a long way to help you with that. Our users and applications, they're running SQL commands on the database, and we want to make sure we can detect anomalous activity, things like, that may be indicative of attempts to break in and steal data from that activity, right? And for that, we'll configure auditing within the database, right? The Oracle database offers comprehensive auditing capabilities, and we'll usually want to audit activities such as database connections, especially failed logins, activity on sensitive fields, activity by highly privileged users, perhaps some specific data control language, things like a creation of users, privilege grants, things like creation of stored procedures, database links, things of that sort, right? All of these are typically fairly rare in databases, so this level of auditing presents minimal performance impact. You can't audit everything. It'll kill your storage. It'll eat up cycles, so you have to be judicious, right? And picking and choosing what you're going to audit. But these are some pretty good candidates to start with. And if you're using DataSafe, DataSafe can extract the audit information into a secure repository for additional some analysis, alerting, and reporting. DataSafe also optionally allows you to control your audit settings, letting you provision policies, enable, disable policies, set up some basic conditional auditing policies to give you further control. If so your users, of course, they're inserting, they're updating, they're retrieving data, and this data is, of course, traveling over your network. And in almost all cases, we'll want to encrypt that data to reduce the chances that an attacker can steal that data. This type of attack, it's called sniffing the network. It's kind of a funny term, but literally it's what they're doing is they're reading this data off the wire. And if it's not encrypted in transit, it's in clear text. So your Oracle database supports two different types of encryption in transit. There's native network encryption, which is certificateless. And then there's the industry standard certificate-based TLS, right? And finally, we'll want to make sure that we know what type of sensitive data resides in the database. Is the baseline security posture we're discussing, is it appropriate for the level of risk presented by the data in this database? Or should we do more to protect it? Here again, we can return to DBSAT or DataSafe, both of which allow us to scan the database for sensitive data, reporting on what types of data are found and how much of it there is. So all the controls we've talked about so far, we consider these baseline. These are the things that we think any database should implement. And everything we've discussed so far, this all can be done without the need for additional cost or options, with the one exception of DataSafe if on-prem. So let's say we've checked our database and we've determined that the data we have here requires something higher than just baseline security. Perhaps there's some intellectual property in there, or personal user data, financial data, or maybe you just have some compliance requirement that requires that you have additional security. So let's see what that would take to kind of go beyond baseline. So in this slide, we've gone ahead and we've cleared out some of the baseline controls to make room for more. But keep in mind that we're building on this idea of the baseline. We're not replacing it. So since our database's data is eventually persisted on disk and in backups and in exports, we'll want to protect it from attack here. And here's where transparent data encryption comes into play. It's very important to distinguish transparent data encryption from something like a storage level encryption or OS encryption, which encrypts your data when your database server is turned off. But what you really want to protect yourself from, the typical use case you're looking to solve for is when your database server is up and running. If a bad actor were to get out to that database server and try to look at the contents of those data files, those .dbf files, you want to ensure that they see those files in an encrypted state and not in clear text. So just keep that in mind. If you're ever in doubt on your own servers, I would suggest you just go out and do a simple Unix strings command if you're running a Unix OS against any DBF file. This could be anywhere that you think is encrypted. And if you can see the contents of that data file, then I would argue that you've gotten a very cheap compliance check, but you're not really encrypted at rest, and that's a big problem, right? So to solve that problem, you leverage Oracle's transparent data encryption. Okay, if we encrypt the data, that means that there's an encryption key that we need to protect and distribute securely. And for this, we use Oracle Key Vault. We also mentioned earlier administrator accounts and the idea of a compromised administrator account. We'll want to protect against a compromise there as well. And for this, we use Oracle's Database Vault. Database Vault works on this concept called a realm. Think of it like a kingdom. I think of it like a shoebox, right? You create one of these realms or shoeboxes in your database, or one or more, and you can put in it different objects. So for example, you could put in a table or a whole table space. Like here's a common use case. Perhaps you have a financial table space. You could create a financial realm. You could put into it this whole table space. And then no user would be able to access that realm. It doesn't matter if it's sys or system or DBA. You'd have to go in and very specifically choose who's going to access it. For example, the finance application user is a great candidate. So you'd give that user access to this realm, right? But you can add multiple other conditions. For example, perhaps the financial application user comes from just a few IP addresses. You'd add those conditions. You'd say, this user can access this finance realm, but they have to come from this IP address, right? Perhaps you have certain developers that need to access that data, but maybe only during, let's say, a maintenance window. You could say, okay, users with this role or these specific users can access this realm, but only Fridays and Saturdays, let's say, from 10 p.m. to 2 a.m. And you can add other conditions to these users. Say, okay, but our developers come from a specific jump box. You can add that IP or that series of IP addresses. And you can even add the program. You can say, hey, our people all use SQL Developer. You can say, okay, all these conditions plus they have to run SQL Developer. And this is very powerful because if you can imagine if a DBA account was compromised, all of these other conditions would have to be met for that data to be accessed. So this becomes a very powerful way to lock down that highly sensitive data. And you can even go one step further and even specify certain commands. If you're a DBA, you've probably had at least one time in your life where you've seen or incorrectly yourself dropped an index to rebuild it during business hours. And it was took much longer than you thought, and you caused an outage. So you could say, for example, for this realm, nobody can drop an index during business hours, right? That's one I would have loved when I was especially a junior DBA, right? So that's Database Vault. We also want to provide some additional protection for our high value data columns like credit card numbers, taxpayer IDs, things of that sort in production. For this, we can use Oracle's data redaction to hide sensitive data on the fly as it leaves the database. Right, so let me explain. The query is run as it normally would be, same execution plan, it grabs the data, but then depending on who's asking for that data, the data that you've chosen to redact and how you've chosen to redact it can be redacted in memory before it's presented. So a very common use case for data redaction is, let's say, a commercial off-the-shelf application. Let's use the example of a call center. You've got this commercial off-the-shelf application that you use in a call center. When the manager uses that application, they want to see all of the data, right? Credit card numbers and everything. But perhaps the person answering the phone, you want certain fields to be redacted for them. So based on their user ID or other factors, you can say, for these users, for these fields in this application, let's present these fields as redacted. Okay, if you're not using DataSafe, we may still want to analyze user activity, secure these audit trails in a central location. produce reports, especially some of these great out-of-the-box compliance reports, which would have saved me many, many hours when I was at DBA. Generate alerts for events of interest, do some database security posture management. For this, we can use Oracle's Audit Vault and Database Firewall. Much like DataSafe, Audit Vault and Database Firewall also assesses database security, tracks user entitlements, and scans for sensitive data. But unlike DataSafe, Audit Vault and Database Firewall can also support audit collection and database firewall support for Microsoft SQL Server, Sybase, DB2, and some other databases. Also, as the name implies, Audit Vault and Database Firewall does more. In addition to tracking user activity through auditing, Audit Vault and Database Firewall includes the database firewall. We'll use the database firewall to examine incoming connections and SQL statements for anomalies and violations of our policies. And if we choose to, we can either flag these or go one step further and actually block out-of-policy activity with the firewall. And of course, events from the database firewall, they flow from the database firewall into our Audit Vault server for additional analysis, reporting, and alert generation. And if you're using our latest version of the Oracle database, 26 AI, it was 23, now it's 26 AI, the firewall capabilities are now built into, will be built into the database kernel. We call it the SQL firewall to differentiate it from the separate database firewall. The SQL firewall checks incoming SQL and connections to ensure they're allowed by policies, and it logs any policy violations. And also, if desired, the SQL firewall can block those violations, stopping the SQL from even being examined by the database. SQL firewall violations, they're available locally in the database and may be picked up by DataSafe for analysis and reporting. DataSafe also lets you manage the SQL firewall, including developing policies. One quick note, the SQL firewall, it's licensed as a part of Oracle Database Vault. It's also included in Oracle Audit Vault and Database Firewall. Okay, there are several database controls that provide more granular row and column level access control. These include things like Oracle Label Security, Virtual Private Database, Real Application Security, and some others. Almost everyone creates these I mentioned earlier, this subprod or the non-prod clones, right, of the database for use in our QA and development and so on. So for these, for the subprod data, we'll simply identify the sensitive data in these databases, and then we will replace it with realistic looking safe data that does not present a security risk, but still allows our teams to do their jobs, the application development, the testing, and so on. If we're using DataSafe, then we can use the data masking capabilities that are built into DataSafe. If we don't use DataSafe, then we can use Enterprise Manager's data masking and subsetting pack. Database masking or data masking and subsetting adds the additional capability of subsetting the data. So for example, let's say we've got some production tables that are very large, let's say multi-million record tables. With database masking and subsetting, you could say, okay, for these certain tables, we only need a few 100,000. And it would do that while maintaining the referential integrity. And because it's built into Enterprise Manager, this is especially useful for orchestrating end-to-end processes like cloning of production databases, masking it for test and development, and so on. So all of these controls working together create what we call the maximum security architecture. Not every database needs all the parts of the maximum security architecture, but many databases need something beyond a baseline security. Okay, thank you for your time. I'm going to pass this off to my peer, John Sartor, for the customer case study. John?
Thanks, Joseph. Good morning, good afternoon, everybody. So in the next section of this presentation, we're going to look at a customer case study from a couple of years ago. This is a healthcare customer who had suffered a data breach at least 2 years, maybe more, prior to when we got engaged with them. The customer reached out to us, stating that they were having trouble deploying this security control in their environment. Um, their goal for that security control was to, following that data breach, was to just deploy tokenization everywhere. So they were going to tokenize or do field level data protection on their data, on all of their sensitive data everywhere. And they had been trying to get this deployed for at least a couple of years. The project had got significantly bogged down. They'd made very little progress in that time. Any success that they did have was met by additional setbacks further down the line as application teams complained about performance issues and some recoverability issues, and then also sort of just long-term management issues as well. So if you can progress to the next slide, Joseph. Whenever we're when we're so what we needed to do during that engagement was to kind of just try to do some discussion and additional discovery and just figure out exactly what problem was that they were trying to solve. And when we're going through exercises like that, it's important for us to kind of bear in mind or be aware of who's accessing the database, um, under what conditions are they accessing the database, and where in which of these areas that we're looking at right now is the customer more concerned about. In this particular case, the customer's primary concern was was on the far left of the slide. So they were more concerned with the database administrator, or specifically database administrator accounts being compromised and leveraged to get access to all of the sensitive data underneath their databases. So they weren't too concerned with sort of batch and scripted processes or even the application accounts connecting to the database. They felt that they had a pretty good handle on securing those data access channels. But they couldn't really figure out, or they didn't really have a good handle on how to protect the data from those privileged accounts. And this was why originally they went with the tokenization solution. I guess their determination through that evaluation process for tokenization was, if we encrypt the data or tokenize the data before it gets to the database, then any privileged account that has access to the database can only ever see tokenized data. And while that's true and accurate, like I said, those solutions are very tricky and difficult to deploy, and there are other factors like performance of the application and the database that needs to be taken into consideration, as we're going down those roads. Those solutions are great for, small use cases where there's a very small subset of very, very highly sensitive data that needs to be tokenized. So think about things like credit card numbers, or specifically those payment account numbers, the PAN, that's part of your credit card. That's a very small subset of data, and tokenization works very, very well in those scenarios. But tokenizing large amounts of data across multiple database systems is extremely challenging, and that's where the customer had found themselves. Through that process, if you can progress to the next slide, Joseph. So through that, in that time and through those challenges, the customer had at some point evaluated transparent data encryption, right? So they'd encountered problems. They tried to look at other solutions. They looked at transparent data encryption from Oracle, and at the time, they rightly determined that TDE wasn't enough to protect the data from the privileged accounts, and they were right in that decision as well, right? TDE alone is not going to protect you against data access from highly privileged accounts. TDE's goal is to prevent bypass attacks at your data, as Joseph previously mentioned, and we'll have a look at that in the demonstration that I'm going to show you here in just a minute. But the goal of TDE is to prevent bypass attacks, right? If you can connect to the database with a privileged account, we still need additional controls there to put into place. And so, Joseph, next slide, please. That's why when we were discussing this, we ultimately, based on their problem statement and what they wanted to protect their data on, and their evaluation of TDE, we were able to position what we call TDE++. Now, TDE++ is not a product from Oracle. It's not an option. It's not a feature. What it is just simply a solution where we combine multiple database security controls to achieve high levels of data protection within an Oracle database. So using tools that are within the Oracle database. So we're not trying to bolt on some third-party tool here. We're using database native tools to achieve very high levels of data privacy and data protection in the Oracle database. Those tools are TDE at the base of it, combined with data redaction, database vault, as well as key vault. So this is a very multi-layered defense in depth approach to securing data inside an Oracle database. So I'll leave the slide in here so you can have a look at a comparison between, what field level data protection is, or, tokenization as well, and how that compares to the solution that we have from Oracle, where we combine all of these security controls together. So at this point, Joseph, can you go to the next slide? What this looks like in practice is something like this, and this was the architecture diagram that we were working off for this particular case study. So we've got most of the components in this slide over here. When we go through the demo, we're gonna focus on a few of the core components in this. So we're gonna have a look at the DBAs. We're gonna have a look at the accessing the data and the underlying data in clear text. We're gonna have a look at those users who can actually, we do want to give access to data. But again, when we're looking at this overall architecture piece, we've got users connecting through to the database via the application, which we're not particularly worried about, but we still need to get some visibility of. We have these DBA accounts who can connect directly to the database, and we don't want to run ad hoc queries, or they can run ad hoc queries, but we don't want them to. And then we've got these data read accounts who can directly access the database and run ad hoc queries. Now, they should be able to run queries, but we want to be able to only, or very tightly control under what conditions they can see the data. And then over on the right-hand side of the slide, this particular customer wanted their InfoSec team to own the overall configuration for this deployment. So the configuration would be sort of implemented by the DBA team in conjunction with the InfoSec team. But once the configuration was in place, the DBA team would hand over control of that configuration to the InfoSec team, who was, again, outside of the database, outside of that DBA team. And even though they were able to grant access to the data and manage data access, they themselves would not have access to the data. So all of these considerations had to be internalized and implemented in this solution, and they were successfully done through the engagement. So at this point, let's have a look at what this looks like in practice. And I'm going to present my slide here. You can move that one. Okay, so we're looking at my terminal session for my database server now. Anyone who's been around for any time with the Oracle database, and I guess there was a poll at the beginning of the call. Vast majority of the folks that are attending this call look like you've been working with the database for certainly more than 2 years, probably a lot longer than that, I would say. So you already know that once I'm connected to the database server, I can oftentimes connect directly to the database without providing a password. So if anyone new to this, who hasn't already seen this before, once we get to the database host, it's easy for us to connect to the database without providing a password. Once I'm connected there, I can see that there are a number of different pluggable databases that I'm working with. So in pluggable database 2, there are none of the security controls that we're talking about. So essentially an open system, right? In pluggable database 1, that's where I've got my TDE++ implemented. So before we have a look at PDB1, let's have a look at what can be done with PDB2. So from this container, I can just very easily move over to the pluggable database. And from here, we can see that I'm still connected as sys, so essentially the owner of the database. And while connected as sys, I can run queries. So I can run select queries from my application schema and my application table over here. And because I'm connected as sys, there's nothing stopping me from getting access to any of this data. So we can see I've got clear text first name, clear text last name, and clear text social security numbers here. So nothing stopping me from getting access. So if we think about those compromised credential scenarios, or we might have a DBA credential being stolen, or a system administrator credential being stolen, and someone getting access to our database host, um, those credentials are key targets because an attacker knows that if they can get them, they can just connect to the database like this, and there are no security controls that are preventing them from getting access to the data. So that's why they go after those accounts. So again, connected here, I can run update state, I can do selects, I can do update statements. So I can do an update and give someone a social security number in here. And then let's reset that. So take a note. So there's nothing stopping me, as we've already established. So take a note of this social security number if you can, ending 4997, because we're going to use it in the next phase of this piece. So now let's exit from the database and let's look at the underlying data structure here. So we already saw that I was selecting from a schema called employee search prod and a table called demo HR employees. That table is stored in a table space called emp data prod. And we can see here that emp data prod is not encrypted. So there's no encryption at rest there. And we can see here that the data file for that pluggable database is here. So if I just do a simple, like Joseph said, using a simple strings command, let's do that one there first. We'll do a simple strings command on that data file. So here's the command that we ran, strings directly on the data file. And we can see that there is obviously clear text data in here. Now this output is a little bit truncated just because there would be tens of thousands of rows being returned in this of text on this page. But again, we can clearly see here that there is clear text unencrypted data. What about that social security number that we were looking at earlier? So let's have a look for that. So just to show you again and reconfirm, we've got this strings command on our clear text data file looking for that social security number that we saw earlier. And we can see here that it's there and just ready to be viewed. I didn't even have to log into the database. I didn't even have to connect without a password. If there's no TDE in there, then I don't need to connect. I can just get all the data that I want from underneath this database. Okay, so that's an unprotected database. Let's look at what it looks like in a clear text, sorry, in a database where we've got TDE++ deployed, or we've got, our database security controls in place. So in PDB1, I have the same schema with the same table stored in a table space with the same name. But in this schema, sorry, in this pluggable database, we can see that emp data prod is encrypted, and it's encrypted with AES 256. Okay. And here's the underlying data file for PDB1. So if I run those very similar commands that we had earlier, let's go, not that one in particular. Let's do this one first. So we'll do it's just a simple strings on the data file. We can, if we have a look at this output, you can see that there's no clear text output in here. All of this looks like ciphertext. There's nothing in here that's going to be, human readable for us. Anything, any 2 or 3 characters that might look like they're human readable is probably just chance more than anything else. What about that social security number? Let's see if we can find that in here. So grep again. So we're doing the strings command on PDB1's data file, and we're doing the grep for our social security number, and there's no output in here for that. So with TDE in place, right, now we need to access the data inside. Now we need to connect to the database if we want to try to get access to data. Before I log in there, we can see here that the keys for this pluggable database, so PDB1, is protected with Oracle Key Vault. So the keys for that database are in OKV, so Oracle Key Vault. So my keys are separate from my encrypted data, right? So I'm connected to the container again. I'm now connected to pluggable database 1, still connected as sys, but now when I run my select query that I was running in PDB2, we can see that I now get insufficient privileges. So what I have in place here is I've got Database Vault configured with a Database Vault realm, and I've got a realm protecting the demo HR employees table inside of my employee search prod schema. With that realm in place, anyone connecting to the database as sys or connecting as a DBA account doesn't have access to that data anymore. So with Database Vault, we now have an additional layer of protection in the database to safeguard that data access. Even if I try to run my update statement that I was running earlier, it just doesn't matter which one I run, I get this insufficient privileges. Because we've got some time left over in our session, let me show you what that looks like here in my Enterprise Manager window. So I'm connecting an Enterprise Manager, connected to my pluggable database. Go to my security tab, go to Database Vault. Let's click as the Database Vault owner account. My system's running a little slow. Once that returns, I'll just show you a couple of screens where we can see the Database Vault configuration. Anything that I'm looking at inside of this screen over here, I can also do with PL SQL packages directly inside the database. So I can configure and control Database Vault using PL SQL packages rather than this Enterprise Manager screen over here. So you'll notice that I logged in as a Database Vault owner account here. So this is a different account. So I've got separation of duties enforced with this. And I go to my administration tab and I go to realms and I go to this protect employee data realm that I've got created in here. And if I click on next, you can see here, this is my realm. So I haven't had to move any data or haven't had to move any tables. It's a configuration construct for Database Vault that enables me to enforce additional protections on data objects inside of my Oracle database. So here's my schema, here's my table. Here are my realm authorizations. So these are the people or the accounts in the database that I want to give access to data within this realm. And then that's it. And my realm is in place and it's enforcing that data protection. Okay. So let's do this logout. The next phase of this is what about when we want those users to connect to the database that do have access to query data inside the database? So I'm going to connect as a user called Pete now. So I'm connected as a user called Pete. Now he can connect to the database and he can run select queries on the data, but because of where he's coming from, or under most conditions, most circumstances when he's connected to the database, we don't want him to see all of the data. There are, he should be able to only see certain data fields inside of this table. In this query over here, I've selected the sensitive ones. So when he's looking at the first name, last name, and social security number, he's only ever seeing redacted values. So I've got a redaction policy in place that does a randomized, random string for first name, full redaction for last name, and a partial redaction for social security number. So there's that social security number again that we saw in the in pluggable database 2. But here we've got this random string for the first name, last name, and then social security number as well. If I go into here, data redaction, let's see if I can. This may or may not work because of the protection that I've got in place. So let's maybe do SecOps because I've probably got more chance of doing that. I'm not sure why I keep switching back, invalidating the password. So because of the protection that I've got in place here, it might not allow me to view my redaction policies. View. Yes, okay, good. I can view it. So here's my redaction policy. So schema. So I've got my schema here. I got my table, and then these are the columns inside of my database that I'm going to have this redaction policy on. So first name we can see here, random, last name, full. So when we do a full redaction, we don't show any characters, and when the social security number, we only want to show a partial. So there's a function here which only allows you to see the last four of the social. That's the enforcement place. That's over there. So what if Pete needs to see the data? So he's got an urgent report that he needs to do, that he needs to produce, and he needs to get access to the actual underlying data. Well, we could set up a break glass scenario or break glass function in here, which Pete could then go and request access or a password for a role, and when he has that role, he can see all of the data. So let's do set. So we're going to do set role. And now if we run the same query over here, we can see that he can see he can see the clearly unredacted data inside of the database. Okay. So the idea here is that, we might put something like this password protected role. We could manage that with something like a privileged account manager, some PAM solution, or some privileged access control, where, like I said, Pete can request the password for this role. Someone else can, review his request. They can grant access to the password. Pete can retrieve the password. He can use the password. And then the privileged account management tool would then connect to the database and reset the password for this role. And so that when he disconnects and then reconnects, he loses access to the role and he goes back to only seeing redacted data. Okay, so what we saw there was the value of combining these security tools together, right? With just TDE, we would still be able to connect as SYS and get access to all the data. So we really need TDE plus Database Vault plus redaction to tightly control access to data. That's why we call it TDE plus plus. So Joseph, can you bring up the slides again for me, please? Thank you. So this is what we went through right now. So if we can scroll on to the next slide, Joseph, there's just the 3 more slides in here, which essentially just summarize, the functionality of the controls in the database and what features of those controls in the database that we used for TDE++. So for Database Vault, we enforced separation of duties. So we had Database Vault owner, and then we took away essentially some privileges from SYS and our DBAs, and so that they couldn't get access to data. So we prevented the misuse or abuse of privileged credentials. And then on the next slide, Joseph, with redaction, we tightly controlled how sensitive data is being presented in our environment. So we had that redaction policy there to control, first name, last name, and social security number. So only under certain conditions can someone get access to that data. They can't bypass those controls. And then lastly, on the next slide, we had transparent data encryption, which was blocking out-of-band access to data at rest underneath our database. So again, you can go and just we'll be sending the presentation out afterwards, so you can review the material in the slide to get a better understanding for this. Brandon, I'll hand it back to you at this point to close it out. Thank you.
Thank you, Jean and Joseph, today for an awesome session. We really appreciate your time and help, and I hope this was a good learning experience for everyone. Awesome. So if you enjoyed this session and you want us to, conduct personal trainings for your organization, we can definitely do that. And here we have a lot of different resources that are free or at no cost to you to learn more, like our free tier tutorials, Code Innovate, which will help you, we'll co-develop solutions with you. And there's also links to documentation and the cloud adoption framework. And of course, we have certification paths as well that are offered through Oracle University. And then we have links to our other Day One and Beyond series, as well as the recorded webinars there as well. And we do offer one-on-one sessions for personal training, and these are one-on-one customized Oracle Cloud training sessions, so they can be 60, 90, or 120 minutes. We also have our newly designed QuickShot Live Labs program for a more hands-on learning experience. Again, this is going to be one-on-one with your organization and our Oracle Cloud engineers. Please remember that personal training is an investment that we make in our customers to help them grow and develop their OCI skills at no additional cost. So if you're interested in any of these additional programs for yourself or your organization, feel free to email us at personaltrainers_us@oracle.com. And our next session will be on December 16th. In this session, you'll be introduced into designing a cyber resilient architecture and how to start off with best practices. So with that, thank you for joining today's session and have a wonderful day.